This is the fourth in a series on magnetism from STEM tutors. What we're going to look at this time is what happens when we have poles that are the same next to each other. In the previous video we talked about magnetic fields joining to create a single magnetic field, and as a result of that they end up attracting each other. It's quite important to remember that magnetic materials actually attract one another. It's not just one attracting the other, it is both attracting each other. So we have two magnets, we have north, south and south, north. The same is true when we talk about if the central two pieces were north as if the central two pieces are south. The truth behind this is that like poles, repel. In other words, they're pushing each other apart. If I was to draw the magnetic field here, I will have a magnetic field that goes something like so. And remember, with magnetic fields I have to draw on the magnetic direct field line direction as well, and it always goes from north to south, so like so. If I do the same for here and here, and draw just a little bit simpler here and a little bit simpler here, arrows pointing inwards like so. You'll notice here that these magnetic field lines are opposing each other. If I were to pull another magnetic field line like so, those arrows will come in like this, and if I pull another magnetic field line, you see they want to cross. But the point about magnetic field lines is they are not allowed to cross. This interaction here is not allowed. So because they don't join up, you end up with them repelling each other. And you can get some fairly complex situations with field lines like this. In the central point here, you have an area where there is a null point. There is no net magnetic force at all working in that area there.